Everyone knows this symbol. It's the one for CO2, also known as carbon dioxide. Now for a little chemistry. CO2 is a molecule made up of one carbon atom and two oxygen atoms, formed by the combustion or fermentation of substances containing carbon, such as wood, sugar, and grapes. But it's also produced when carbon-rich fuels like coal, natural gas, and oil are burnt. Although CO2 has always been essential for life on Earth, there is actually very little of this molecule in the atmosphere, 0.038% to be precise. But this tiny percentage plays a huge role in the greenhouse effect. The greenhouse effect. Does that sound familiar? It's a natural phenomenon that traps solar heat in the atmosphere and keeps the temperature warm enough for all forms of life to survive. Without it, the temperature would be 18 degrees below zero. But today, the greenhouse effect that used to protect us has become a threat. Industrial production, mass consumption, and modern comforts have led to a steady rise in the use of fossil fuels, which release CO2 into the atmosphere, causing global warming. The effects of rising temperatures are spreading fast worldwide and are difficult to control. If we don't act now, temperatures could climb by 6 degrees by the end of the century, sparking a series of events with consequences which could be irreversible. Melting ice at the poles, swelling oceans submerging coastal regions, concentration of greenhouse gases acidifying the sea and disrupting marine ecosystems, desert areas increasing and expanding. Time is running out. By now, everyone is well aware of the sources of CO2 emissions in the atmosphere. 40% come from power generation, 20% from transport, especially road transport, 20% from industry, and the final 20% from household consumption. But how can we reconcile our growing need for electrical energy with the fight against climate change when electricity production represents nearly half of CO2 emissions in the atmosphere? The answer lies in the new society that is emerging. More energy efficient, more digital, with the use of more electronic devices and virtual interactions. And above all, a society in which clean sources of power can help meet the new emerging needs. With Alstom, there is a clear path to a world with better control over its CO2 emissions. While Alstom plays an important role in reducing CO2 emissions in the field of transport, power generation has its own set of challenges. Alstom engineers look to a variety of solutions for their answer. They have identified 3 levers for combating climate change, with each complementing the other. The first lever involves making greater use of energy sources that don't release CO2, such as hydropower, wind power, solar energy, biomass, marine energy, geothermal energy, and nuclear energy. It also means developing intelligent solutions for storing these forms of energy and connecting them to existing transmission networks. But this lever must be combined with other methods in order to be effective and meet all of the planet's needs. Alstom helps improve the energy efficiency of power plants, which use fossil fuels to generate electricity. In 2030, 2/3 of CO2 emissions will come from plants currently in operation. The challenge is to produce the same amount of power with less fuel and lower CO2 emissions. New coal-fired power plants will soon reach efficiency levels higher than 50% and up to 60% for natural gas plants. Finally, Alstom has become an expert in a third solution, the capture and storage of CO2 released by power plants. This solution works with all fossil fuel plants and results in the production of carbon-free energy, even if the raw materials themselves contain carbon. All of this is happening while we wait for an alternative to fossil fuels, which we'll still be depending on for decades to come. So how does it work? Alstom specializes in 2 CO2 capture technologies for power plants: post-combustion, which involves capturing the CO2 after combustion, and oxy-fuel combustion, which produces concentrated CO2 resulting from combustion in nitrogen-free air. In both cases, the idea is to isolate CO2 to avoid its release into the atmosphere. But then, what do we do with the remaining CO2? Well, once it's captured, the CO2 is dehydrated and compressed in a liquid form. It can then be safely injected into the deep porous rock of sedimentary basins at a depth of 1,000 to 3,000 meters, where it gradually dissolves into the brine, the highly salty water present in the basin. The CO2 can also be stored in depleted hydrocarbon reservoirs. And this process is completely safe for 3 reasons. First, the CO2 is injected into a natural reservoir topped with impermeable rock. Second, part of the CO2 is trapped in the rock's pores, preventing it from moving. It then gradually dissolves into the reservoir's saltwater. Third, the CO2 will harden into minerals over a very long period of time. 13 Alstom pilot sites worldwide, including Mountaineer in the United States and LAC in France, have already proven the worth of this technology. It is now ready to be put into service for the first time in large power plants before being widespread. The stakes for the planet are considerable. By 2050, CO2 capture and storage could eliminate up to 1/5 of the CO2 coming from power generation. With its technologies, Alstom is offering solutions that ramp up the fight against global warming. It's a long struggle that has only just begun.